These are the section 9.3 notes, and we're going to start talking about how we can take quadratic functions and we can transform them. And I went ahead and I wrote in the vocabulary words ahead of time. So I'm going to read through them, and then I want you to pause the video and write them in for yourself. But before we get started, you need to have your textbooks open to page 544. You should probably have a ruler. I would said 3 different colors of pens or pencils because we're going to do some graphing that shows transformations, and then anything else that you might need for graphing. I'm also going to use a calculator. So, transformations change the position or size of a figure. The figures we're going to be talking about today are the parabolas that are formed by quadratic equations. So it's going to change where it sits on the graph, so it might move it up or down, left or right, or it could change its size. And a translation is the first kind that we're going to talk about. It's the kind of transformation that just moves it. So it's saying it's going to keep its shape and size, but it's going to move up, down, left, or right. Now a vertical translation is up or down, right? So when a constant c is added or subtracted from the parent function, which we know is x squared, the graph of the parabola is translated up or down. We're assuming that c is positive. So all it's saying is I'm taking the parent function x squared and adding c. That's going to move it up. So if this is my original function, so the parent function goes through the origin. If I add c, all it does, it keeps the exact same shape, but it moves it up however far c is. So this function would be x squared plus c. Now I can also say x squared minus c, and all that does is move it downward. So same kind of thing, it keeps its size and shape. It just moves down on the vertical or y-axis. So this would be x squared minus c. So let's try a few of those examples. First thing we're going to do is graph the parent function. So I'm going to go ahead and draw my axes. I'm just going to draw them in the middle of everything. So I'm going to draw one right down the middle. For my x-axis, and right down the middle for my y-axis. Or f of x. And the first thing I want to do is I want to graph that parent function. So I'm graphing a parabola. We're going to make this one be pink. So first thing I have to do is find the vertex. Vertex is negative b over 2a. I don't have a b, so it's negative 0 over 2 times a, which is 1. So I just get 0. F of 0 is just 0 squared, which is 0. So my vertex is at 0, 0. Okay? Then I make a t-chart. I have 0, 0 as my vertex, and I'm going to go 2 to the right, and 2 to the left and 2 to the right. So I'm going to have negative 1, negative 2, and then 1, 2. So f of negative 1 is negative 1 squared, which is just positive 1. F of negative 2 is negative 2 squared, which is positive 4. Now these are symmetrical, so I'm going to go ahead and make this 1 and this 4, and then plot my points. And then draw in my curve. Okay? This function is f of x equals x squared. Okay? Let's go ahead and graph the second one. Now this one adds 3. It takes that exact same function but adds 3. And I'm going to do this one in green. So we're going to find the vertex. Now this is the same thing as f of x equals 1x squared plus 0x plus 3. b is still 0, so my vertex, I get negative 0 over 2 times 1, which gives me 0. However, when I plug it in, f of 0 gives me 0 squared plus 0 plus 3, which is 3. So my vertex is at 0, 3. Then I'm going to make a t-chart. And I get 0, 3. I'm going to go 2 to the left and 2 to the right. So I get negative 1, negative 2, 1, 2. And I'll start plugging them in. If I have f of negative 2, I get negative 2 squared plus, and then we're not going to worry about this, 3. So negative 2 squared gives me 4 plus 3 gives me 7. So I get 7 here. And then f of negative 1 gives me negative 1 squared plus 3. So I get 1 plus 3, which is 4. These are symmetrical, so I can say 4, 7. So negative 2, 7. Negative 1, 4. 0, 3. 1, 4. And 2, 7. And then I can draw in my curve. And do you see how they have the same shape? It's just moved up. So this would be x squared plus 3. Let's go ahead and draw in that last one. I'm going to use purple. Now notice this one has a minus 4. So it's going to shift things down 4 places. So I have 3, which gives me my vertex of negative 0, because again I don't have a middle term, over 2 times a, which is 1. So I get 0. When I plug that in, I get f of 0 gives me 0 squared minus 4, and I get negative 4. So my vertex is 0, negative 4. Draw in a t-chart. 0, negative 4. I'm going to go 2 to the left, 2 to the right, so negative 1, negative 2, 1, and 2. Plug them in, so I have f of negative 2 gives me negative 2 squared minus 4. So I get 4 minus 4 gives me 0. F of negative 1 is negative 1 squared minus 4. So I get 1 minus 4, or negative 3. These are symmetrical. So I have negative 2, 0, negative 1, negative 3, 0, negative 4, 1, negative 3, and 2, 0. And then I can draw in my curve. And this is x squared minus 4. So all of these things have the same shape and size. They are just moved up and down on the graph. Now a dilation is another kind of transformation, and it makes a graph either more narrow or wider, so it changes the shape and size of it. And then that's actually pretty easy, and so instead of adding or subtracting, we're going to multiply. And when a parent function, x squared, is multiplied by a constant a, the graph of the function is either stretched or compressed vertically. It's either made, so what that means is it's either wider or skinnier. If a is bigger than 1, so like 2, 3, 4, all of those numbers, it is stretched vertically, so it's made skinnier. And the way I like to think of that is, because sometimes when it's like, I'm multiplying it by 4, so it should get bigger or wider, but what we should really think about is, it's going to make it taller, faster, so it gets skinnier. So it is getting bigger, but it's getting bigger upward instead of outward. So if it's bigger than 1, it goes upward and gets taller and skinnier. However, if it's smaller than 1, so if you see fractions, it's going to be wider, okay, or compressed. So let's go ahead and talk about that. If I have f of x equals x squared, I have just the original parent function. Now if I have f of x equals 2x squared, it's going to make it skinnier. Now it doesn't move up or down, it stays with the vertex at the same place, it just changes everything above that. Okay, so this would be f of x times 2x, or anything bigger than 1. Now if it's multiplied by a fraction smaller than 1, now 3/2 is a fraction, but it's bigger than 1, so it would still do this. But smaller than 1, so like 1/2, it will get wider. So it will do this. It will still go through the origin, but all the other points will be made wider. Okay? So go ahead and turn the page. We're going to do a few examples. First thing we're going to do is graph that original function. We're going to use t-chart from the other page, so we don't have to do all that work again. So go ahead and draw it right down the middle again. I'm actually going to draw this on the bottom. I'm going to draw that y or x-axis down towards the bottom. Okay. So we're going to use this t-chart for the parent function. So I know I'm at, and I'm going to make it pink again, 0, 0, 1, 0, and 2, 4. Negative 1, oh sorry, this was 0, 0, 1, 1, and 1, or 2, 4. So now this one is negative 1, 1, negative 2, positive 4. Okay, drawing your curve. Okay, this is the parent function. Then let's draw in number 2, or g of x equals 3x squared. Now, I'm multiplying by a whole number that is bigger than 1, so it should get skinnier. Okay, let's do that one in purple. So we're saying 3x squared. To find the vertex, there is no b, so I have 0 over 2 times 1, which is just 0. So f of 0 gives me 3 times 0 squared, or 0, at 0, 0 as my vertex, which makes sense. We said that they should touch at the origin or at the same place. So then I have to make a t-chart with values to the left and to the right. Okay, I'm going to go negative 1, negative 2, 1, 2. Now f of negative 2 is going to give me 3 times negative 2 squared. Order of operations says I have to do the negative 2 squared first, so I get 3 times positive 4, or 12. F of negative 1 gives me 3 times negative 1 squared. Again, order of operations says do the negative 1 squared first, so I get 3 times 1, or 3. These are symmetrical. Okay, so I have negative 2, 12. Okay. Negative 1, 3, 0, 0, 1, 3, and 2, 12 again. And this is 3x squared. And it did get skinnier just like we wanted it to. Okay, I'm going to do number 3 in green. Now notice it's being multiplied by a fraction that is smaller than 1. So this one should get wider. So I have 1/2 x squared. So my vertex, we already know that my vertex should go through the origin. So we're not going to do that work to find the vertex. It'll just be at 0, 0. Now I have my t-chart. I'm going to use negative 1, negative 2, 1, and 2. F of negative 2 gives me 1/2 times negative 2 squared. Order of operations, so I have 1/2 times 4, so I get positive 2. F of negative 1 gives me 1/2 times negative 1 squared. Order of operations says I have 1/2 times 1, which is 1/2. These are symmetrical. So when I plot them, I go to -2, 2, 1, 1/2, or sorry, -1, 1/2, 0, 0, 1, 1/2, and 2, 2. So when I draw in my line, I get something like this. And that will be 1/2 x squared. And it got wider just like we said it should. Okay? Another kind of transformation is called a reflection, and a reflection is just like it says. It reflects or flips the parabola or figure over a line. Now there are two different things that can happen for reflections, and it's important to remember the difference. If I take f of x equals x squared, the whole function, and multiply it by -1, so just like down here I take the whole function and I get at negative f of x equals negative x squared, the graph is reflected over the x-axis. So this is the x-axis. Let's come down here and take a look at that one. So when I multiply the whole function by -1, it flips it over the x-axis and makes it look like this. It turns it upside down. Okay? So this becomes negative f of x equals negative x squared. The other thing that can happen is you can multiply just the variable by -1. So what it's saying is when f of x has its variable x multiplied by -1, so look down here, it's f of -1 times x equals -1x squared. So notice how this one is not in parentheses and this one is. There's a big difference, okay? You have to pay attention to those things. The graph is reflected over the y-axis. So that is this example. So you see how we have just a regular f of x. It flips over here, so it stays right side up. It just changes to the other side and flips. So this becomes f of negative x. So this is negative f of x, and this is f of negative x. There's a big difference. This one makes it upside down, and this one just turns it over to the other side. Go ahead and turn to the next page. We're going to do a few examples. So if I have the parent function, we're going to use table from the other chart, or from the other page. So we don't have to do all that work again. So you can go ahead and draw in your axes. Go ahead and draw them right down the middle. Okay, and I'm going to make this one in pink like I have been. So I have 0, 0, -1, 1, -2, 4, 1, 1, 2, 4. Okay, now let's go ahead and deal with that second one. I'm going to do it in purple. So I have negative x squared. This one is not in parentheses, so turn back to the other page. Which one is not in parentheses? It's the number 1 example, so it's going to flip over the x-axis and come down here. Let's see how we do that. So my vertex is still going to be negative b over 2a. I don't have a b, so I get 0 over 2 times -1, so I get 0. F of 0 is negative 0 squared, so I get 0. So I still have my origin as my vertex. Draw a t-chart, and I'm going to go -1, -2, 1, 2. F of -2 gives me negative 2 squared. So notice I did put some parentheses in here, but that negative did not come inside the parentheses with it. So I get negative positive 4, so -4. F of -1 gives me negative 1 squared, which gives me -1. This is symmetrical. So I have -2, -4, -1, -1, 0, 0, 1, negative 1, and 2, negative 4. So, if I draw in my curve, I can see that it's the same size and shape, but it just flipped to the other side of the axis. So I get negative x squared. Now let's go ahead and add in one more graph. We're going to do h of x let's go h of negative x, okay? And we're going to put that inside parentheses. So actually, cross that off. We're going to say h of x equals, and inside parentheses, negative x squared. And let's see what happens. Actually, that's not going to work. Because if I take the original graph and I flip it, it's going to look the exact same. So that's why on this back page, I had this one over to the left. Because when I flip it, you can actually see a change. So we're going to not worry about this last part. So those are your notes for section 9.3. Let me know if you have any questions.